morning, everyone. Welcome to today's session. We would just wait for a couple of seconds more so that we have more people joining in. Hey, hi, good morning, everyone. Thank you for joining in. We'll just wait for a few more seconds. Great. Good morning to everyone who's here. Thank you so much for joining the next session, which is organized as part of Control plus T Testathon. Today we have Vishnu, who is the lead solutions engineer for HyperExecute at LambdaTest. And we also have Prateek, who's senior automation analyst. And they will walk us through HyperExecute and answer all your questions. So HyperExecute by LambdaTest is an IP-led product of ours that helps customers run and orchestrate test scripts in the cloud for any framework and programming language at blazing fast speed. And Vishnu and Prateek would be walking you through what HyperExecute means and how to go about it. So over to you, Vishnu.
Thank you so much, Kavya. Hi, everyone. This is Vishnu here, and I'll be walking you through the our unique IP called HyperExecute. So to begin with, myself, Vishnu, I'm working as part of a solution engineering team here at LambdaTest as part of the HyperExecute product, right? So to begin with, HyperExecute, it's what exactly HyperExecute is. We'll get into that. This is a quick agenda of the today's session, like what all we'll be covering so far, right? So to begin with, what is HyperExecute? HyperExecute is the most intelligent test orchestration platform to run your end-to-end test at the fastest speed possible. Yes, speed is the prime aspect of it, but there's much more to it. We do have more features than speed as well. And to get with HyperExecute, you get that localized execution, like how you get on your local machines, the speed you get on, and that too with the benefits of cloud. That's the prime idea of HyperExecute, with a bit more of smart orchestration features. So HyperExecute is a language and language framework and platform agnostic product for end-to-end testing, and this is a quick snapshot of what all popular frameworks and tools are supported on HyperExecute. And it's not just limited to this. Even if there is a custom framework that you have developed in-house, we can support that on HyperExecute. This includes all kinds of OSs. That's Mac OS, Windows, Linux containers, even mobile devices like iOS as well as Android. Right. So why HyperExecute? So with HyperExecute, we claim to be almost 70% faster than any standard Selenium grid. So when I say standard Selenium grid that's running on cloud, LambdaTest also has its own Selenium grid available. And as compared to that, HyperExecute is claimed to be almost 70% faster. It has zero test flakiness due to the infrastructure tight coupled architecture. And with HyperExecute, you get deep insights, analytics. There's no kind of maintenance involved on your end. The release velocity increases, right? So before we go into how HyperExecute was built, I'll just talk on why the traditional solutions are so slow. So when I say traditional solutions, I'm referring to the standard Selenium grid. So this is a quick snapshot of how the network calls happen from your local script to the browser when a test is fired up. So let's say you have a script, you fire it up from India, from your local system, right? It connects to a hub that might be residing in Singapore, right? And then it connects to a data center maybe in Europe, and then eventually it is trying to connect to the website. The browser is opening up the website as part of the test case that's hosted in the US. So as you can see, it's almost traveling halfway around the world to just communicate to the website and run that particular UI based or any kind of test case. So there are multiple network hops involved in this kind of architecture, and due to which we are not in control of the execution environment, due to which the network latency increases, and there can be network drops, and it's difficult to triage at times when we are debugging a test case, or we are debugging a failure when it comes to when we are running on normal automation grid. So now when it comes to HyperExecute, we have combined the first three modules, the script, the hub, and the browser, into a single Azure VM, and the only network hop happening would be towards your website. So we have combined the first three objects, so that what happens with that is it would provide you an in-house like self-contained environment, so that there's minimal network latency involved there. The only network hop is towards your website, and due to which the speed in turn is like comparable to your local native system, right? And it supports all kinds of frameworks. Like if you have a codeless tool like Catalan, Tosca, if you want to run any framework, Selenium, Playwright, Cypress, everything is supported with HyperExecute, right? And it is integratable with any kind of CI/CD pipelines as well. So some of the key features with HyperExecute, right? As you can see on the screen, I'll just go one by one, and we'll get deep into it when I start with the live example. So it's HyperExecute follows a YAML-based workflow where you can define how you want your project to be run with HyperExecute, right? To optimize your test execution as well as orchestration. We do provide smart orchestration features like auto split, test reordering, retry on failures, data splitting, static and dynamic test discovery. We'll get into detail in the coming slides. We do have fail fast, where you can get a faster feedback to your developers or to your test life cycles. We do have customizable test environments where you can use the pre and post directives to define how your project should be run, or if there are any prerequisites needed for that project or for that test suite to be executed efficiently. We do also have dependency caching, where all the relevant dependencies as part of your test suite can be cached, and so that it minimizes the time for the consecutive executions. Along with that, we also have the test artifact management. So let's say you have any artifacts that are generated as part of your test execution. We can save that onto our like storage, and you can access that later directly on the HyperExecute dashboard. So yeah, so one of the key features, like prime features, is smart test orchestration. So with HyperExecute, what you can do is, let's say you have a set of test cases, and with HyperExecute YAML and the CLI, it can be smartly distributed using the auto split strategy, so that it gets distributed over different VMs in the most efficient manner. Along with this, you can prioritize your jobs. So if you have multiple jobs running, so just by providing that label, like with the priority, that this has to be a high priority job, a medium, or low, with that priority, you can just define which one should be run first, and that one would be picked automatically based on how you have defined the labels. HyperExecute also supports smart auto retry mechanism. So when, for example, with just adding a parameter in the YAML file, it defines like how many times you want to retry a failed scenario. And within that particular stage itself, if a failure is recognized, it then and there itself retries that particular test. The benefit of this is you don't have to go through that hassle to create that retry logic within the framework. Nowadays, there are certain frameworks that by default provide this, but there has been some legacy frameworks that do not have this feature, and you have to create that logic within the framework itself so that it retries if a failure is occurred. But with HyperExecute, it's just a plug and play. You can just enable the automatic retries in the YAML file, and it would take care of the retries how many times you want, and that's it. So faster feedback loop. With fail fast as a feature, you can shorten your like feedback loop. So what happens with fail fast is you can define like for how many, if let's say if there are 4 consecutive failures, it would just abort the complete job and it won't wait for the complete job to complete. So that's kind of a feature that fail fast is. Along with this, with smart orchestration, there is automatic test reordering also. So what happens is, let's say you have 100 test cases as part of your job, and last 10 test cases fail. So what happens is when you run the job again next time, the failed ones would be reordered in such a way that they run in the beginning, so that you don't have to wait for the first 90 to complete and then you go to the failed ones. So the failed ones would be executed first, so that you get a faster feedback of how the if there were any changes and if there were any changes that to those particular test cases. This There is a catch here that this would happen when the test cases are independent. For dependent test cases, we'll follow a different approach. The distribution happens in a different way. So the HyperExecute environment can be completely customizable using the pre-steps and post-steps. So for example, let's say we had a use case where one of the there was a requirement for authentication using a certain certificate installation on the VMs, right? So we can leverage the pre-step to install that particular certificate, add it to the trusted root, and then uh, continue towards the test execution. So that's one of the examples how the pre-steps can be used. You can have certain API scripts to be running in the pre-steps if there is any prerequisites needed. You can have database connections to be set up in the pre-steps before the actual test begins. So these are certain examples how you can use the pre-steps. Along with that, we have post-steps as well that comes into picture after the test execution completes. With the post steps, you can have some post cleanup actions if there are any deletions to be needed within the as part of the test case. You can do that using the post steps. If you have any privately hosted websites, any behind the firewall environment, that can be used by using our tunnel feature. So with HyperExecute, using the tunnel feature is fairly simple. You just have to add that parameter in the YAML file, and that's all. Everything else is taken care by the HyperExecute CLI. I'll come to the CLI, how it works, right? And in case you don't want to use the tunnel and you prefer whitelisting of IPs, we do provide dedicated NAT proxy for any kind of private assets if you want to access directly using just whitelisting. Also, we do support scheduling of jobs with like whenever you want. So we do have workflows where you can define like for how when you want to run your job, you can schedule them accordingly using those workflows. Right. So integrating with HyperExecute is just a 2-step process, right? One is the YAML file, which I was talking in the previous slide. So this on the right side, as you can see, this is a snapshot of how a YAML looks like. One thing is this, and the next one is the HyperExecute CLI. So CLI is a lightweight binary which actually packages your test scripts and puts it onto the HyperExecute VMs for execution. And that CLI follows the YAML steps that what all we have defined in the YAML file. It follows that approach, and then accordingly it starts with the execution and the job. So I'll now move on to a sample Selenium project of how we can integrate your existing project with HyperExecute, right? So I'll just quickly move on to my project here. So this is my sample Java TestNG project. As you can see, this is the YAML file in front of me, right? So there are a bunch of parameters, as you can see here, which I'll go in depth one by one. So So there are certain timeouts here which you can define, like for how long the job can be run. So global timeout is the complete job timeout. So that's 150, and this is in minutes. So you can have it up to 150 here. And then we have test suite timeout, test suite step timeout. There are different types of stages available on the HyperExecute dashboard, which I'll show you in the next coming minutes, right? With runs on, so this is the OS that you want to run on this particular job. So you can define Windows or Mac or Linux, right? So all three OSs are supported in case of desktop. You can define it using runs on here. Then we have auto split as true. So there are multiple types of modes on which HyperExecute jobs can be run. One is auto split. Then we have another one as matrix, and the third one as hybrid, which is kind of a combination of matrix as well as the auto split mode. So with auto split, there is a test discovery involved. So what happens with test discovery is it actually discovers all your tests based on how you want to run your test or which particular test you want to run. So this is a grep command that I'm using. So grep is just a utility to filter out different text, right? So this is a grep command I'm using to fetch the test name from this particular XML file I have. So testng follows an XML to trigger the test. So this is my XML here. And as part of this sample, I have 4 different tests that are part of this XML. And the test discovery that I just showed you here would be discovering all those 4 tests that are part of this XML. So I'll just quickly run this command so that it's more easier to understand. So this is my terminal here. If I run this grep command, I can see these 4 tests, test 1, 2, 3, and 4. These were discovered as part of this particular XML file. And these 4 are 4 different classes I have here. So this is the test discovery involved in this particular project. Then we have the test runner command. So I'm using an Maven-based project, so I'm using MVN test. And these are some additional parameters as part of this particular framework. And deselected test is the parameter used to run a specific test, right? And I'm using this $test variable here. So what $test does is the output of this test discovery is saved in a variable called $test. So dynamically, for example, I have 4 tests discovered. So when the auto split distribution happens, it distributes these tests onto different stages, different VMs, and each one would have a unique test. So I have 4 tests discovered. In the $test, one VM would have test 1, the other one would have test 2, third one would have test 3, and then the fourth one would have the test 4. So that's how distribution happens. Each VM gets its own test, and they would be running in parallel depending upon the concurrency I provide. So there's one more parameter called concurrency here, which defines how many machines, how many VMs you want to be spinned up for this particular job. So I have right now 4 set as concurrency, so 4 different VMs would be spinned up. So then we have retry on failure. So this is what I was talking about, automatic retries. So you can just set it to true, and you can define how many retries you want. It's just set to 1. So if a test failure is occurred, it would retry once. So right now there are 4 different tests I have. So just to demonstrate, I'll just quickly change locator here so that a failure is occurred, and accordingly it would retry that particular test then and there itself. Right, so we covered the test discovery, the test runner command, and then yes, the pre-steps. So pre-steps are the prerequisites, pre-directives needed for the project to run. So in this case, I'll be using an MVN command to resolve the dependencies. You can use an MVN clean install, MVN install to install all those dependencies that are part of this pom.xml of this project, right? And this pre-step takes care of that. Pre-step also can include other scripts as well. Like let's say if you want to run a custom Python script you have in the project, you can do that using something like that, right? If you want to install any certificates, as I mentioned, you can use certutils. And this is like direct access to that particular machine's terminal. and you can perform any command line operations directly. You just have to list them down in this YAML file, and it'll be taken care of while the execution starts. That's how pre is configured. Then we have post steps also. So right now this only has a cat command to just print contents of this YAML file, but this again has direct access to the terminal of that particular VM, and you can perform any custom script executions, any additional post cleanup actions in the post steps. Then we have artifact tree management. So with execution, there might be certain artifacts that are generated. There might be certain reports that are generated that you want to access after the job completes. So with just adding this upload artifacts parameter, you can provide a certain name here and just provide the expected path. So this sample project, there is a target folder involved and where the Surefire reports are generated. So I've provided the path as target, Surefire reports, HTML, and double asterisk, so that all the contents of that HTML folder are uploaded as part of the artifact tree, and I can access that later. So with adding this upload artifacts, I can access those artifacts directly on the dashboard once the job completes. Next on, we have reports. So we do support different kinds of reporting based on different frameworks. And this is constantly being added as well as part of like recent development. So as part of this framework, I'm using an extent reporting, right? And I just have to provide the location where that report would be generated, what would be the type of that particular report, and what's the framework. So let's say I'm using an extent report. So I just provide the name extent. If it's a Cucumber or JSON type report, I will just change the type to JSON and change the framework name to Cucumber. So that particular report would be generated. So that's how reporting works. So this is like a brief overview of how a YAML is configured, and this is just the auto split mode. So now to execute this, what you have to do is we need to keep the HyperExecute CLI. So that's the binary that I was talking about. One is this YAML, and then we have the HyperExecute CLI binary. So this is the binary I have already downloaded and kept in the root of my project so that it has access to all the files that are present within the project. So once I have the CLI present here, I have the YAML configured here. All I have to do is I need the HyperExecute run command to trigger this particular CLI. So I can get the run command. So this is the HyperExecute dashboard, right? These are all the different kinds of jobs and how a summarized page looks like of the HyperExecute dashboard. I'll just quickly go to this help center, go to HyperExecute CLI. And this is the HyperExecute command that would be used to trigger the test. So this includes HyperExecute, my username, the access key, and config. So config expects the path of your YAML file. So I'll just copy this. I'll go back to my terminal and paste it here. And here, as part of the config, I'll just copy the path of my YAML file and paste it here. So that's it. I have my command configured, and as soon as I hit enter, it would start with the execution, and it will show you what kind of mode you are using. It's an auto split mode. You're using Windows as runs on, and you have the concurrency of 4. That means 4 different VMs would be spun up. So now the payload is created, it's uploaded. Now we can directly go to the HyperExecute dashboard, and I can see here I have a job in running state. So this is my job that's running, and this is how it looks like. These are the 4 different VMs that were spinned up. And if I go to pre-steps, I have different kinds of stages here. Cache download, pre-discovery, scenarios, and post-steps. So in the pre-steps, as you can see, I'm using that Maven dependency resolve or Maven clean install. So all my dependencies would be installed right here, right? Once the dependencies are installed, then is the test discovery part. So we had the test discovery, which discovered 4 different tests as part of that XML file. So this particular machine, this particular VM got the test 1. The second one would have got another test 3. And third one again, some other test like test 2, and the fourth one with test 4. So this distribution is random because these are independent test cases. And so now if we move on to scenarios, so this is the stage where the actual test runs. So you get the live console logs here, as well as the link to the test here itself. So you'll get both the logs under the same dashboard, which also makes it easier to debug. You don't have to go like from your local to remote or something like that. You'll get the live execution logs, as you can see here, and this is the test hyperlink. So as soon as you click on this view test, it will take you to the automation dashboard, where you get access to the live test execution. You can play the video while it's executing. You'll get the command logs as you saw on the cross-browser testing automation session. So this test-specific dashboard is shared amongst the normal automation grid as well as HyperExecute. But the video you see, this is part of that HyperExecute VM, and the speed you see it's comparable to your local native execution. You get all the relevant command logs, same as is. You get the raw Selenium logs, console logs, everything, right? And all the relevant metadata that was as part of this test case. And you can directly go back to that particular HyperExecute stage by clicking on View on HyperExecute. It will redirect you back to that particular HyperExecute stage where this of which this test was part of. So yeah, once the test completes, it moves on to the post steps. If you have any post steps configured, that would be executed here, along with those logs would be printed. We do have artifacts that were created as part of this sample. So these were my artifacts that were software report HTML, and all the contents of that HTML folder. So as you can see here, I click on artifacts and I have the artifacts available here. So we get a folder structure. You can directly get into that. And if you want to just open any specific file, you can do that as well. All the contents are available here. You can open it directly. It'll open up in a new tab. For example, yeah, this was the extent report as is, as I can see here. Also, if you want to download it directly, you can download individual files, as well as you can download the whole artifact folder directly from this particular download artifact button. So that's how artifacts are being managed. We also had a report configured, the extent report, which can be downloaded by clicking on this report button. So as soon as I click on this, it will download that HTML report onto my machine, and I can just directly click on this HTML, and yeah, this is the HTML report, how it looks like for this particular sample, which has relevant information on what was the browser covered, what were the operating systems, how many test cases were there, different kind of metrics around that, what was the framework of the that particular report, which was the user, job number, all kind of metadata. In detailed view, you get like summary of what all test cases were there, what were the steps involved in that. So this data is directly picked up using the traditional extent report. These steps are mapped here, and we generate this report as part of HyperExecute. Under the test case, you'll get all the relevant test links that were part of that particular job. So you can click on this See video, so it will take you to that automation page where you can directly watch the video, right? And so yeah, this is how you can watch the video. Or if you directly want the test summary, just click on this View Test, and it will take you to that automation page where you get the test summary of that particular test. So everything can be easily navigated through that report. And right, so we also had enabled automatic retries. So I had a failure here. So as you can see, one failure was one error was detected, and it also provides you detailed and information of what kind of error it was. So as soon as you click here, so you get the logs and at what step it failed. So you get so I just changed the element, so it could not find that element, so I got an element not found error. and you get like analysis of this failure, why it happened, and this changes on based on how what kind of failure it was. And you can also directly like filter out the stack trace of that particular failure, right, using the failure analysis tab. And this is how, yeah, a retry attempt looks like. So I had set it to 1, so one time it retried, and yeah, it executed once again. So this is how it looks like. Because it was an intentional failure, it failed again, and I got the same error here as well. So yeah, this was a brief overview of how you can like integrate with your existing project. We do have other modes as well. For example, I was talking about the matrix mode. So matrix mode is more used when you want to test more different kinds of browser OS combinations, right? Where you can define what all browsers to be covered. So with matrix, you can control which test you want. There is no test discovery here. It's not an auto split mode, it's a matrix mode. So what happens is you can create different arrays, different matrix. For example, I'll just show an example. So I'll just create an array of browser. I want to run Chrome, Firefox, and Edge. Right? So what happens is all these 4 tests would now be executed on all these 3 browsers. So it would multiply both the arrays as part of the matrix and create those many number of combinations on the HyperExecute job when I trigger it. I can also define OS here. So let's say I want Mac and Win. So, and now under the runs on, I can simply define matrix.os. So now the runs on would pick up values from the OS array of the matrix, which is Mac and Win. So what would now happen is Mac would be, so all these 3 would be multiplied, right? So Mac gets all the 3 browsers, Chrome, Firefox, Edge, with all the 4 different tests. So if I just run this particular YAML file, so that is the path of this, I'll use the same command. This is the matrix YAML. Everything else remains the same. I have the same test runner command, same prerequisites, artifacts, report, everything. Just we have replaced test discovery with the matrix so that we can define which test you want to run. So right now there are 4. I'll just change it to 1 so that it's easier to understand. So now test 1 would be executed on all 3 browsers on both the OSs. So as soon as I click enter, it will start the execution. It will show me that, yeah, it's the matrix mode, and now it's trying to create the payload. If I go back to my HyperExecute page, so because I had one test on 3 different browsers on 2 OSs, it has created 6 different VMs. So one with Mac test 1 Chrome, one with Mac test 1 Firefox, Mac test 1 Edge, and then Windows test 1 Chrome, Windows test 1 Firefox, and Windows test 1 Edge. So this is how a matrix execution looks like. You can use the matrix to run your regression across multiple browser OS combinations by just providing the values in the YAML file. And the execution would have its own, yeah, pre-steps, discovery, scenarios, everything similar to how it runs. The third mode is the hybrid mode. So hybrid mode is a combination of both matrix as well as auto split. So if you want the test discovery to be involved and you also want that flexibility to run it across different browsers combinations, you can use that hybrid mode in that case. So yeah, this is how you can integrate your existing project, right, with HyperExecute. And the YAML file is completely customizable. So this was a pretty straightforward example, but we can have the test discovery how you want it. If you don't want to use an XML, you have a different strategy to follow. Maybe you might have certain Excel files that define how the test cases are written, or if you have certain jars, everything is completely customizable within the this particular YAML file. So yeah, also with we covered the YAML right. So one thing I think I missed. So as part of the prerequisite, within the test case, we have to configure a remote web driver that's connecting to the LambdaTest hub. So this is the remote web driver. I think this was covered in one of the cross-browser testing sessions. So this is one of the prerequisites when we run on HyperExecute, so that you have to configure the remote web driver so that it points to hub.lambdatest.com along with the relevant desired capabilities and everything. Everything else remains the same. So this is one of the prerequisites needed when you're running on HyperExecute. And so this is how you can define the YAML and everything. Also, the HyperExecute CLI also has some additional like capabilities. Like if you want to, I'll just do a quick help here. So as you can see, there are multiple parameters how you can set certain parameters at runtime. For example, if you want to download artifacts right after the job completes, you can use the download artifacts flag. It will download the artifacts right under your project here itself, so that you don't have to, if you don't want to go to the dashboard, you want to access this directly on your project, you can do that using the download artifacts. You can also download the report. You can download the artifacts as zip, right? We do have a no track flag. So with no track flag, what happens is if you run an execution with no track, so after the so this is helpful when you don't want to utilize the that particular VM or that particular instance to keep waiting until the HyperExecute job is completed. So as soon as I use the no track, it after the payload upload completes, it would just quit this particular terminal and everything else happens on the HyperExecute dashboard. You won't get anything back. So you can just free up this particular runner by using this no track flag. So yeah, so as soon as the job link is created, you get access to the terminal, and that instance is completely free. Now you can have any other actions or any other like jobs to be performed. You can use this instance for that. Similarly, there are a bunch of other parameters that you can explore, right, with the HyperExecute CLI. So that's a quick, like that's a kind how you can like integrate your existing project, a sample project, with HyperExecute, right? Then we'll move on to Tosca on HyperExecute, right? How you can configure your Tosca workspace with HyperExecute. So for this, we do have a projects page. It's comparatively very easy to configure. So as soon as you go on the projects page from the HyperExecute, you can set up a new project, and then you have the you can select which tool you want. You can provide the project name here. I'll just provide test project. And as soon as I click on continue, it'll show me like what all details it requires for this project to set up. So it'll expect a license, a Tosca commander license. You can provide the username and password. If there's a cloud server ID, you can provide that server ID as well. Then it expects what kind of DB type you're using for that workspace. So this has to be a multi-user workspace because we are using a common repository to connect and get that information. So you can select which connection type it is, what kind of connection data. You can use both connection data or connection string to set up that particular workspace, and then the username and password of that particular workspace once you have configured all of this. So I have inputted everything else before, and I have my sample project available here. So as soon as all those information is input and you save it, it actually discovers all the execution list that are part of your particular workspace, and it would list them down right here itself. So what you can simply do is you can just select which execution list you want to run by just clicking on this checkbox. Let's say I just select multi-browser demo and SAP Fiori 1, right? So I just selected 2 and I can just click on run. It will ask me like how many VMs you want directly on this page. So I'll just select, let's say 2, right? And then you can also enable automatic test distribution based on test entries. So it would distribute different test entries that are part of that execution list. And as soon as you click on run, it would start the execution. You'll get the notification here that you can go to the jobs to view the execution. And this is my project. This is my Tosca project that I just executed directly from my projects page. So as I selected 2 as the concurrency, 2 VMs were spinned up, right? It also includes a pre-step where the information that I provided, like the cloud server license, it validates that license first in the pre-step and sets up that workspace. And then in the scenarios, it would start with the execution. So while this is running, I have a previous run here. So I'll just quickly walk you through how it looks like. So as part of the discovery, there were 2 different test entries within this multi-browser demo execution list, which were discovered and distributed within this particular VM. Similarly, I had another execution list selected, and that was distributed here. And this is that particular test entry which had. And under scenarios, I'll have 2 different stages. One is the create sales order and web API. If I expand this, I'll get the logs, the TC shell logs. And to watch the video, I can just click on watch video and just play it. So I'll get the live video of that particular test, how Tosca Commander executes it. So this is the sample SAP test case, which creates a sales order and saves it. So once the execution is completed, what happens is all the test results and everything can be directly fetched onto your Tosca workspace itself. I'll just wait for this particular execution to complete. Once this is done, I can simply go to my Tosca workspace and simply do an update all. So all my test results would be updated onto my Tosca workspace, and I can get that report, get that logs of which what all test cases were covered, how many passed, failed, and all the statuses of that. So I'll just wait for this execution to complete. So similar, you can watch the video. You can download the video if you want. Yeah, while this is running, I have my Tosca commander opened up here inside a particular VM. So once that execution would complete, I can simply click on update all, and all the relevant logs and everything would be updated right here along with the relevant timestamp. And I can access the logs and see the status of what all steps were covered and everything right under my Tosca workspace. So this was one of my previous executions. This was successful, and the web API web was failed. So I can see which particular step would failed right in the Tosca workspace itself. Yeah, I think this one is a slightly longer test, but yeah. Okay, so I'll just move on to the next slide. Yeah, so HyperExecute dashboard concept. So the HyperExecute dashboard has multiple stages. So I'll just quickly walk you through step by step, like what all terminologies are being followed here. So this is a summary of how the job page looks like. So these are all the jobs. As you can see, all my jobs are listed over here, and within each job, as soon as you click on these are for, like, we call them as tasks. Each VM has its own is its own task, right? And each task has their own like cache download, pre-step, discovery, the scenarios, and the post steps. So cache download is the step where it actually checks for if there's a cache uploaded in the previous run. So this is where the smart dependency caching comes into picture. So when you execute your job once, and if the cache is enabled in the YAML file, that cache is stored, and as soon as you go and like run another job, it would look for that cache and use that cache downloading to get the cache, and it would use that directly, and it won't download a fresh from the Maven repository if the cache is there. So that saves a lot of time. So let's say if it takes around 2 to 3 minutes or even 15 minutes to install certain dependencies when it's a fresh machine, with the cache download, it would hardly take 10 seconds. So that is the step here. Then pre-step, as I already mentioned, like to install all the dependencies. The discovery step is where all the discovered tests would be displayed. So if this particular VM had 4 tests, it would display those many number of tests, right? Scenarios is the stage where the test step is executed, where the actual test is executed. So you can just expand it. You will get the console logs of that particular scenario right here, and also under the test associated, you get the test links here. And if there are more tests than one in a single stage, it will just show you 1 plus more, and you can just click on this and it will take you to that particular test. So there can be multiple tests in a single stage. There can be a single test in a single stage. So that is completely dependent on how the tests are written in the framework and how we are distributing them using the YAML file. So that's, and you can have multiple scenarios here as well. So this particular sample had 4 tests be distributed on 4 concurrency. So let's say if I just select, for example, a concurrency of 2, and I still have 4 different tests. So what would happen is it would distribute my 4 tests onto 2 different VMs, and each VM would have 2 tests there. But in that case, what happens is, since we are spinning up 2 different VMs, only 2 tests are running in parallel, and the next 2 are waiting for the first 2 to complete. So that's how the distribution happens here. So yeah, this one is the job I just triggered. So with the concurrency of 2, so with the pre-steps, download the cache. Once it's complete and the discovery is done, we'll be able to see how many tests were there. So yeah, so test 2 and 4 were picked up by this VM, and the remaining 2 would be picked up by the other one. So now 2 of them would be running in parallel, 2 and 1, and 3 and 4 are just waiting for the first scenario to complete. So that's how a distribution and auto split works here. If you have more number of tests to be run on less number of concurrency. Yeah, so in the dashboard concept, then we have the post steps. So post step is the same as we described before. We can have post, you can have artifacts, and then after the artifacts, once the execution is complete, you get the cache upload step here, which actually uploads the updated cache every time once the job execution completes. Yeah, so along with this, we do have something called as secrets, right? So with secrets, what you can do is, if you don't want to expose any particular credentials that are part of the test suite, you can define them in secrets here. Just add, click on add. It's a key value pair approach. So and the secrets is backed by HashiCorp here. So we are using a HashiCorp vault to save these secrets. You can provide a key name and the secret value to it and add new secret, and it would create a new secret under the secrets page, which you can directly use it by providing the name of the secret here. So in the YAML file, for example, if you want to create a variable, or if you want to create an environment variable using this, just provide the name of that, and using this particular syntax, it picks up that secret using the from the vault. So now I can use this pat environment variable anywhere across my project to access that particular secret that I have stored. So, okay, so this one got completed. All my execution list and Tosca were done. So now if I go back to my workspace here, I can just do update all. So now it has updated my execution list that were executed with the latest execution information. So this is my today's date. Yeah, and this one has failed on the same step. No batching tab was found. And similarly, all my execution lists, so whatever were covered in this particular execution, like my test case, multi-browser demos, SAP Web API test, everything would be updated here itself. Right, so this was my SAP Web API test, which was successful. So I get the report, the log directly here itself. Right. So yeah, these were some HyperExecute dashboard concepts, how we define different kinds of stages and different steps that are part of the HyperExecute page. Yes, and HyperExecute is easily integratable with any of your CI/CD pipelines. So it's also, again, a two-step process. All you have to do is in the pipeline, you can simply use this HyperExecute, this curl command to download. So you have to download the HyperExecute binary depending upon the OS. So if it's Windows, you can use the Windows URL. If it's Linux or a Docker, you can use the Linux-based URL. Once it's downloaded, you can provide permissions to it, and then executing the command, the HyperExecute CLI command, by the same command that we just used to trigger the HyperExecute binary, which includes HyperExecute username and access key, and the path of that YAML file. Only these two steps are needed, and it would be integrated with your existing CI/CD pipelines, irrespective of what you're using: Jenkins, AWS, Azure pipelines, DevOps, GitLab, etc. So the same step is followed across all the CI pipelines, just by downloading the binary and executing the binary using the command. Right. So yeah, so I think that was a quick walkthrough of what HyperExecute is with different platforms. I'll just leave it for any questions around the platform now, so we can address them.
Vishnu, we do have a question from Curry for Tosca execution. Artifacts and all we didn't define right, or how it does it work exactly?
Okay. When it comes to Tosca, okay. Right. So so with Tosca, it's completely based on the UI on the dashboard itself. We're not creating a YAML file for that. So as part of the first integration, we have developed like to connect to the multi-user workspace and get the report back into the Tosca workspace itself. If I think if there are any additional artifacts to be configured, what we can do is from the projects, while setting up, I'll just while setting up the new project, I'll just provide name. So yeah, so if there are any additional artifacts to be same, you can provide the artifact path right over here. So that's how you can configure the artifacts.
Cool. And also, if you can, shed some light over the hybrid mode as well. So Ashutosh has a question regarding, can you explain the hybrid mode in detail in terms of YAML configuration changes?
Okay, sure, definitely. So when it comes to hybrid mode, okay, so I'll just quickly, right. So it's pretty similar to how an autosplit YAML looks like. So all you have to do is in the autosplit YAML, you can define a matrix, right? And let's say you want OS, Mac, and Win, right? And then you want the browser to be defined as well. For example, Chrome and Firefox. So as I mentioned before, it's a combination of matrix as well as the auto split mode. So now what would happen is it would create like as part of the discovery, I have 4 tests and they would be executed across all these particular browserized combinations. So there is one more parameter involved here that's called parallelism. So yeah, parallelism set to 1. So this parallelism defines on like how many VMs should be spread up across each OS. So now if I trigger this auto split, so this is the hybrid mode now because I included the matrix and the parallelism. So now if I use this, oh, sorry. Yeah. So there's a dynamic mode. Right. So now this is how the hybrid mode looks like. I'll just quickly go to the dashboard. Yeah, so based on my matrix, it has created those many number of combinations, and each VM would have all the discovered tests distributed within them. So Mac Chrome, Mac Firefox, Win Chrome, Win Firefox, and each one would have like 4 tests there. So all the 4 tests would be executed on Mac Chrome as well, Mac Firefox as well, Win Chrome, and Win Firefox as well. So this is when you want the test discovery distribution, as well as when you want to leverage the matrix to define different browsers combinations.
Yeah, thank you. And also, if you can just help us to understand more about the static and dynamic mode discovery.
Sure. So yeah, so when with test discovery, what happens is there are two types of test discovery also involved. One is static, which I had earlier, and the other one is dynamic, which I just changed it into. So hybrid mode only supports dynamic discovery as of now. So what's the main difference is when we change it to static mode, what happens is this test discovery, it discovers your all the test cases in your local machine itself as soon as the CLI starts. So if you have noticed in the previous execution, this is the tests that were discovered, and this plays a key role with the orchestration as well. So because we already have the number of tests that has to be run as part of this job with the static mode. So now it has the benefit of like distributing the test so efficiently, so that before even going, like before even the execution starts on HyperExecute VMs, it knows that yeah, I have my four of these tests, and it has to be distributed on these many number of VMs. It also helps in resource utilization. For example, if you have less number of tests and you have selected the concurrency of 4, for example, if you have 2 tests and you have selected a concurrency of 4, it would, because it knows like I have only 2 tests, it won't spin up 2 more tests, 2 more VMs. Like it would just override the concurrency to 2, so that because it knows like I have only 2 tests, so only 2 VMs would be enough. That's how static works. So discovery is done here itself as soon as you start the execution. With the dynamic mode, what happens is it actually discovers a test onto the HyperExecute VMs after the payload is uploaded. So what happens with that is there, if you go, so this one had dynamic discovery. So it discovers all the test cases, and after the discovery happens here, then it distributes the test on the available concurrency. So that's the difference between dynamic and static mode. More efficient test orchestration happens when you're using a static mode here.
Yeah, thanks for that. And so we have a question from Kari again. So what are the capabilities we need to add to get the logs? So if you can explain where we are creating the capability object and the other capability set like visual and the command logs.
Sure. So the capabilities are right defined where we are actually creating the driver, right? So these are all my relevant test capabilities. So to make it easier, I'll just quickly open the capability generator, which can be used to generate all the supported capabilities that can be used as part of your LambdaTest execution. So if you go to the help section here, click on capability generator. So yeah, here you can select which browser you want, configure advanced, which OS you want, the screen resolution. So everything would be generated on the right side. So this is my resolution capability with this particular value. If you want to run on specific Selenium version, you can define that here. Driver version, if you want headless to be enabled, everything can be configured using this capability generator. All the custom capabilities. So screenshot captured on every command. So this is the visual capability, like visual set to true. If you want, so by default, the video is recorded. If you don't want it, that's fine. With tunnel, for example, if you want to set up, like connect to your local network, you have to spin up a tunnel and enable tunnel as true. This is in case when you're running on normal automation grid on the standard Selenium grid. But when it comes to HyperExecute, you don't have to define that in the capabilities. It can be configured. Everything is managed by the YAML only. So you can just set that up there. You can also select which type of console logs you want. So these are browser console logs. You can define like if you just want error, warnings, info. So the console set to info. So it will get all those console logs onto the dashboard. You can enable network logs using network set to true. And using once all the relevant capabilities are generated, you can just copy it and simply paste it onto your like desired capabilities object or browser object right here. Since I have already pre-configured them, so yeah, here you can configure all those capabilities.
Yeah. Also, can you show from where the user can see the capabilities and the logs?
Sure. So in the automation page, when you have enabled, let's say, network logs, so here you'll get all the relevant network logs, right? So with respective, you can filter out JS, CSS, image, etc. You can also download them directly. It downloads the network.json, which you can like use it, like if you want to analyze them locally with individual requests and responses, you can do that using the download button. We also support HAR files as well for network logs. That has an additional capability, network.har set to true. So you'll get the HAR format as well. Then under the logs, since I had console logs enabled, these are the browser console logs visible here itself. Selenium logs are enabled by default. These are raw Selenium logs, which can be viewed here. Then we have the terminal logs. So this is an additional space that we have provided. For example, if you want any custom logs, any custom log4j logs, etc., that are generated as part of your test case, you can use certain API. So we do have a terminal logs API that can be called using this particular session ID to be uploaded onto here, and then this terminal logs would be generated here. Again, this would be beneficial when you're running it on a normal grid. With HyperExecute, terminal logs are right away present on the HyperExecute stage itself. So you don't have to go into that hassle of uploading the terminal log separately.
Yeah, it's kind of a platform where you're getting everything in one single umbrella.
Right.
Yeah. So we have another question from Devashish. Can we pass the concurrency values from the CLI? So yes, we can pass the concurrency value from the CLI. So Vishnu, can you just show?
Yeah. So if you define, so as I showed earlier, in the help section, we do have the concurrency parameter, hyphen concurrency. So if I just run the same auto split again and I provide the concurrency as 1, right? So it would honor the command line parameter, and yeah, so now the concurrency is set to 1.
Yeah. And we have another question from Svitha. What are the benefits of using Tosca with HyperExecute?
So when it comes to benefits, with HyperExecute, you are getting like so when you run Tosca on your local systems and that, so what happens is Tosca takes control of your complete machine, and you like probably won't be able to perform any other actions on that on your local machine while you're executing the test, right? Even if it's running on a cloud, it's still that runner actually takes control of that particular machine, and you won't be able to perform any other actions. With HyperExecute, once that project is configured on HyperExecute, you just have to select and just execute it. It's the LambdaTest infrastructure now which is being used for your execution, and you also have access to your local system, and you don't have to like wait for the execution to complete to perform any additional actions. Along with that, with Tosca on HyperExecute, you get similar test orchestration capabilities as you get for any other framework, like test retries, test reordering, and everything else, whatever we provide with normal HyperExecute, you get with Tosca as well.
Right. And in additional, it actually helps you to scaling it up. So the parallel execution is something which helps you over the HyperExecute. Now, suppose you're running parallel execution over your local system, right? It provides you much more flakiness in your test cases. But over the HyperExecute, there is no such dependencies. The machine is dedicatedly provided to run the Tosca test cases only, and the Selenium test cases only. So that is one of the benefits. And the other side of it that you're getting a logs, much more log, verbose log. Now suppose when you're running it locally in your system, there's a limited number of log you will get, just like command logs or the video logs and the extra things. But on HyperExecute, you're getting everything in a one single umbrella: the command logs and the video logs and the Selenium logs. So it will be much more easier for users to debug those test cases.
Yep.
Yeah. And also we have a question from Alka regarding the test discovery. So is there any other command we can use instead of grep command to discover the test cases?
Yes, absolutely. So this command, the grep command we're using, this is just an example. So you can use any command that actually basically lists down that particular set of test cases. So for example, let's say if I'm using a Cypress based project, I can simply do an ls, right? For example, if I'm using a Mac OS machine, I can simply do an ls and provide the path of this folder, right? So if I do this, what it would do is it would list down all the files present inside that folder. So test discovery command can be anything you want, which actually lists down all my test cases. This is just an example. You can use grep, you can use find str, you can use any kind of Unix based or command line utilities to basically fetch and list down your test cases which you want to distribute and uh, for the auto split test discovery. Yeah.
God, thank you. And also, can you just help us to understand much more about the retries mechanism? That how many max number of retries you can do, and what is the default value?
Right. So with retry on failure, you can define the maximum number of retries here. So let's say if you want to set, so maximum you can have it up to 5, right? You can have up to 5 retries. So and the default value is, I think, set to 1. Yeah. So based on the max retries, you can just select. If I select 3 on the HyperExecute stage, so since it was selected to 1 only, just retry it once. If I select 3 now, it would retry it 3 times. And as soon as so right now it has an intentional failure, but if it genuinely passes in the second retry itself, then it will move on to the next stage. You can have those maximum number of retries how many times you want by just defining max retries and with the relevant number of retries here.
Yeah, thank you. And Monali, you also have another question. If any test case is dependent on another test case, is there anything to execute such cases using HyperExecute?
Sure.
So yeah.
Yeah, go ahead, Pratik.
So yeah, we do have the mechanism over here. Like now suppose there is a discovery of the test cases, we can define the ranges of the number of test cases discovered. So you can define the range into the YAML file, that from which X number of range to Y, you can distribute that particular test case in a one single VM. So it is going to be done sequentially in that particular machine, as it's dependent on each other.
Yep.
And we have another question from Basant. What is the fundamental difference in use case between the remote cross-browser automation and HyperExecute?
Okay. So yeah, so the basic fundamental difference, as I mentioned in the beginning slides, that is the overall architecture of how the normal standard automation follows. So because there are multiple different hops happening, there are multiple different like geographical locations being used when it comes to a standard automation grid. So I'll just quickly rewind that. So for example, if you have a script you're running it from India, it connects to the nearest hub. Let's say that hub is in Singapore, right? And then we have the data center in Europe, maybe where the browser is residing, right? And so as you can see, the script connects to the hub. The hub connects to the remote browser, the VM, and then inside that VM, your website, the application that is being tested, is accessed. Maybe that's hosted in the US, one of the US East one, something like that. So as you can see, with the normal standard grid, your script, your test case is traveling from India to US, like covering Singapore, Europe, towards the US website, right? So there are multiple different network hops happening there, and and network plays a key role in this particular kind of architecture. There might be latency involved, right? There can be test flakiness due to different network drops or some other. We don't have control over the execution because that's completely based on certain networks, right? And the tracing can be slightly difficult here because you don't know where it failed, like at what point it could have been failed. So with HyperExecute, what we did is the script, right? The first three components, the script, the hub, and the browser, everything is under a single Azure machine. It's packaged together in the same VM. So now what we are doing is we are clubbing we are packaging the scripts. It follows the fundamental of Cypress, if to make it easily understandable. So it packages the scripts and uploads it onto the VM first, the HyperExecute VM. So inside that VM, we already have the hub pre-configured. The browser, it's there itself, right? And then the execution starts in the same machine itself, and it hasn't have to travel anywhere other than that particular VM. And the only one network hop happening is towards the website. That's the only thing, because website is something that that has hosted from your end, right? So that is something that we can't control. But yeah, the first three components, the script, we send it to the machines, the hub is there, and the browser is there. So that's how we minimize the network latency, and that's how the speed factor kicks in. So this now acts like, for example, if you are running it on your local system, on a local driver, acts similarly like that. So that's the difference of how when you run it on normal grid versus when you run it on HyperExecute.
Right, and there's another factor which I would want to add it. Like suppose there's a user need to more concern about doing their test suite running in parallel, right? But here in the HyperExecute, what we are doing with the help of the strategies of writing the YAML file with the auto split and the metrics and the hybrid, all the overhead of running the test suite parallel is taken by the HyperExecute now. So now you can just just give us the test cases, and the HyperExecute will take care of the rest things, right? And that is how the HyperExecute is helping to the user, and user can mainly focus on their craft regarding running their writing their test cases only, right? Other things, the execution, the doing the parallelization, and doing the distribution, that rest can be taken care by the HyperExecute. And we have a question from Mamta as well. Is there a HyperExecute faster than the Playwright? Or and you can take it as a, how to execute the Playwright test cases.
Right. So similar to how we configured the Selenium based test cases, we do have Playwright also similar. So what it does is basically, so I'll just quickly show you the quick start page. So yeah, these are this is a quick start page that we have, and we can I'll just select the Playwright here. So let me show you an example how it works. I'll just use the get pod to configure the workspace. So it's pretty much similar to how we configured the YAML for Selenium TestNG project. We just have to create a YAML which would have like same pre-steps, a test discovery which would list down all my spec files, right, all my test files. So yeah, this is how it looks like. So when it comes to Playwright, we are using npm install, right, npx playwright install, so that the relevant Playwright version that you have in your package.json is installed on the VM itself. And this is how the test discovery looks like. So we are using the grep command to get all the describe provided in the test list. So it discovers all the tests, like I have 4 different spec files here, and it distributes it amongst like 2 concurrency. So as soon as I triggered this, it has started the execution. So now if I go back to my HyperExecute page, so yeah, this is my Playwright test being executed now. Same pre-step installed my package.json dependencies by using npm install. Then the test discovery has like 4 different spec files. And yeah, so this is the execution that got started. You get the live logs here and you get the view test link. So yeah, similar to Selenium logs, you get like Playwright command logs here. So again, when it comes to Playwright, also when you're running it on remote versus HyperExecute would be definitely faster because it's within the same network itself, and it's an controlled environment rather than sending it onto a remote hub on the CDP grid that we have. But the approach we follow is pretty much the same. We have a YAML file, we have the relevant parameters, and according to the Playwright framework that you have, you can customize the test runner command, discovery, pre-step, and everything.
And again, another question from Mamta, that is there any limitation on numbers of the VM count which tests could be distributed automatically, or any limitation on the test count to be executed on VMs? So,
Okay, so yeah, go on, Pratik.
Yeah, so there is no such limitation of the over the VMs, how many VMs you want to get to run your test case or HyperExecute. It totally based upon the number of licenses and the concurrency the user bought in. And is there any limitation to distribute test cases on each machine? So no, there is no such limitation to distribute the test cases on each machine. Although we recommend users to having a consistent performance to have only 40 to 50 numbers of the test cases on each VMs. Yeah. Vishnu, if you want to add anything in that answer.
Yeah, I think you were spot on, Pratik. So there is no, I mean, as a recommendation, we suggest to have like maybe 30, 40, 50 in a single VM. Like for example, like you can have like 30, 40 as scenarios in here. But based on how many number of parallels you're subscribed to, those many number of VMs can be spun up and be executed concurrently. So what happens, for example, if you have a plan of, let's say, 10, and you just select like 20 concurrency, in that case, what would happen is it would just spin up 20 VMs. The first 10 would be in the running state, and the rest would be queued up. So we do have a queuing mechanism also here. So they would be waiting for the first 10 to complete. So that's how the queuing mechanism works, similar to how we have the same queuing mechanism in automation.
Also, Vishnu, if you can show us that if in the metrics mode, now suppose there is a test case which is in a different folder path, right? So how user can actually define those paths into the metrics mode, the test cases and into the different paths.
Okay, so with matrix, so these are direct like string values. So if you want to okay, I'll just take an example of the Playwright one here, right? So here, as you can see, I have this matrix named methods, and these are the paths that are provided, like it's part of the spec folder here. So let's say if I have these two spec files listed down in another folder like test and I just paste it within this folder that is part of the test folder again. So now I can simply, to run these particular tests, just copy the relative path for 2 and 3. So just replace it here. Yeah, so now I have the updated path in the matrix mode. So you can have customized path, like from the root of the project. Actually, it should be a relative path so that the HyperExecute CLI has access to this path directly. So this is how you can define different paths in the matrix, and they would be picked up on individual VMs now.
Thank you. Yeah, and guys, if you have any other queries and questions, please let us know in the Q&A box.
Great. I don't think we have any more questions in the Q&A box. Vishnu and Pratik, thank you so much for your time. Really appreciate this. To the audience, it has been a really interactive session. Thank you so much for all the questions that you asked. I just wanted to take a minute to quickly talk about a couple of instructions. So all the 5 certifications, right, for the leaderboard score, we'll be considering the scores, the points that you're earning for all the 5 LambdaTest product certifications till 8 June 12 p.m. IST. That is tomorrow till 12 p.m. IST, right? If you're able to complete the certifications and are able to earn the scores, we'll be adding it to the leaderboard. All your session scores are also being added. I understand that there are few participants who have faced issues with regards to the session points. Please write to testathon@lambdatest.com in case you're facing any discrepancy so that we are able to resolve it on priority. We are also looking into the existing use cases that are coming in so that we can address those as well. We have at 3 p.m. today, we have HyperExecute quiz. I would request you to join in on time. And please make sure that you're using an Accenture.com ID to fill in the quiz. So the quiz would be of 30 minutes, you would have time from 3 p.m. till 3:45 p.m. as usual, so as to address the quiz. So yeah, these are the 3 things. The certifications, you could complete it till 8 June to 12 p.m. IST. And tomorrow, by the end of the day, we would also be declaring the top 10 folks in the leaderboard who will be joining uh, you know, the finale challenge. We also have another session scheduled for tomorrow, so we hope to see you over there. Thank you so much, everyone. Hope to see you at 3 p.m. Have a great day. Bye. Thanks again, Vishnu and Pratik. Bye.
Thank you.